Good day to all, dear subscribers and viewers of the channel. Vitaly Sokolov with you. Today we will look at another interesting game engine for creating games of different genres for different platforms. And before we start, put your thumbs up under the video, subscribe to the channel, and write a comment. This is important for promoting the video. Godot Engine is an open-source cross-platform 2D and 3D game engine licensed by MIT that is being developed by the Godot Engine community. This license allows you to use the engine unlimitedly for any requirements, change it and do whatever you want with it. Programmers Juan Linietsky and Ariel Manzer started developing the engine in 2007, and after a while it was already used as a proprietary software product in some companies. In February 2014, the developers decided to make the technology open and posted the source code for the engine under the MIT license on GitHub under the name Godot. Happens in this development environment in C++ and C. The developer environment runs on Linux, OS X, Windows, Bahamian dollars and Haiku, and can export game projects to PCs, consoles, mobile and web platforms. Current platform support includes Windows and OS, macOS, X11, Linux, Bahamian dollars, Android OS, iOS, HTML5. You can also export to other platforms manually by compiling the engine for the target platform SDK. The general architecture of the engine is built around the concept of a tree of inherited scenes. Each element of the scene node can become a full-fledged scene at any moment. Therefore, during development, you can easily change the entire architecture of the project, expand its elements in any direction and work with complex scenes at the level of simple abstractions. All game resources, from scripts to graphics assets and game scenes, are stored in the project folder as regular files and are not part of the complex project database. Assets that are not complex data are stored in simple text formats, for example, scripts and scenes, as opposed to models and textures. These solutions make it much easier for different development teams to work with version control systems. The game is created using its own high-level, dynamically typed scripting programming language called GDScript, whose syntax vaguely resembles the Python language. The difference from Python is, first of all, the obligatory definition of the scope of the variable through the var keyword and the optimization of the language for the needs of the system of scenes and engine nodes. It is possible to use scripting in C++, D, Rust and other languages through the GD Native system. GD Native is an add-on for any programming language. With its help, you can program in those programming languages that are most convenient for the user. There is also a version of Godot with support for the C number language, Godot Engine Mono version. At the moment, this engine supports the largest number of programming languages internally in comparison with competitors. Visual programming, visual scripting, is also available, similar to Blueprints. For example, on GitHub there is a library source code for working in the Object Pascal language inside the Godot environment. During the existence of this engine, a number of games have been written on it. But there are no big popular projects on it yet. I suggest watching a small video cut from games on the Godot engine. Godot has a visual editor for working with scenes, objects, programming and all aspects of real-time game creation. The engine interface supports a huge number of languages. This really makes this engine stand out from the rest. The graphics system for all supported platforms is built on OpenGL ES 3.0. To create shaders, a simplified shader language is used, which is a close subset of the GLSL language. Godot has a separate graphics engine for 2D, not 2D over 3D simulation, that can be used independently of 3D. This allows you to significantly reduce the load on the computer when running 2D games. This feature is not available in many popular 3D engines. The engine supports the following file formats: BMP, Direct Draw Surface, UpNXR, RGB image format, JPEG, PNG, TrueVision TGA, SVG, Web, WAV, Vorbis, GLTF, FBX, Collada, and OBJ file interchange format. The engine site has an asset library. Physics engine for 2D and 3D is designed from scratch and very well optimized. The possibilities of raycasting, collision detection, dynamics of rigid bodies and connections between them, kinematic controller of the character and vehicles are implemented. Other possibilities: multi-threading, scripts run in parallel threads and can create them themselves. Plugin system, plugin can be written in C++ or script. Occlusion culling and the portal system objects. Render targets, rendering an image from a camera to a texture. Mesh detail levels, reduce the load on the GPU. Light baking, mixing static global and dynamic direct lighting. Visual shader editor, a shader program can be created in a visual graph editor. Navigation mesh, for building paths based on polygonal meshes. A search algorithm, fast algorithm for constructing paths in simple matrix grids. Texture atlas, can significantly reduce the load on video memory on mobile devices. Support for Theora video codec, video can be output to texture. The audio system supports ARG Vorbis and WAV codecs, OGG Vorbis for streaming audio and WAV for audio samples. The input system supports keyboard, mouse, gamepad, and touchscreen. Different devices can be assigned to an abstract action, and it will be considered regardless of the input method used. Conveyor for import, export, compression of textures, flexible system for working with assets and auto-converting to the required formats. Pipeline for importing complete 3D scenes. For example, from Blender you can import a scene along with lights, cameras, collision meshes, portals and animated characters. Quite fast compiler, allowing you not to spend a lot of time waiting for the project to compile. There is support for plugins. The source code is open for revision and modification. Works even on very weak computers due to low system requirements. There is a visual editor, animation editor, tiles, instancing and so on. You can export a project to almost any platform. For some it is problematic to do this. The engine weighs about 50 megabytes, which is just a tiny size for such a powerful tool. This is suitable for weak computers with small hard drives. But because of this, the user needs to install various libraries such as Android SDK and NDK himself. Godot is pretty fast and the games built on it are well optimized. Cons of the engine. The engine documentation is available in many languages, but it is not broad enough and not deep enough, but work is underway on it, and the documentation itself is also built into the engine itself, which is quite convenient. Things like memory management, shaders, resources and the like are not done by the engine, but by the user. But on the other hand, it allows you to more flexibly customize and optimize your game. Summing up, I can say that this engine is still rather damp for powerful and large projects, but if desired, they can be done in it. This engine is one of the best for creating 2D games. It has excellent optimization in them. Godot can also be used as a starter game engine from which you start creating games. A huge advantage is the ability to program in almost any programming language convenient for you inside the engine. There is simply no such possibility in other game engines. And the most powerful argument in favor of using this engine is that it is completely free forever, even for commercial projects. As well as completely open source engine codes, which can be used both for learning and programming and for fixing bugs or adding new features to the engine. That's all for me. If this video was useful to you, like the video, subscribe to the channel and press the bell so as not to miss anything new. Vitaly Sokolov was with you. Good luck to you all in creating new games. All bye and see you in new videos.